Plate tectonics, why the Earth is like it is.
The Earth is made up of 5 layers: the inner core, the outer core, the mantle, the asthenosphere, and the lithosphere.
The crust is thin. Okay, when I say thin, I mean maybe tens of kilometers, but compared to the size of the Earth, it's thin. So think of it as being thin. Now, the crust and the upper mantle together are what make up the lithosphere, which is about 100 kilometers thick, somewhere there.
Ever wonder where mountains and volcanoes come from? Well, the theory of plate tectonics describes these things, and it shows how the Earth's outer layer is made up of plates, which have moved throughout the Earth's history. So think of the Earth's crust as an egg, and the crust would be the shell, and the inside would be all of the other stuff that make up the Earth.
Continental drift was a theory by a scientist by the name of Alfred Wegener. Now, Wegener said that the continents were all put together in one big landmass, and he had some evidence for that. Mostly, scientists thought he was crazy. Well, until evidence showed that he was right, which we'll talk about in a minute.
Okay, look at the pictures on your right. What did the Earth used to look like? The theory says that it looks like the top left picture, and eventually the continents moved to look like how we recognize the Earth today.
So, what's the evidence? That's what we keep asking. What's the evidence that continents have moved? Well, one thing, fossils have been found on the African plate that matched up with fossils in the South American plate, which would be evidence that perhaps at one time those animals lived pretty much side by side. So that's the first clue. There's some climate clues that gives you some ideas. For example, there's evidence of a tropical biome in Antarctica. Well, that would only happen if Antarctica had moved. So at one point it was in a very warm place, and now of course it's in a very cold place. And of course there's rock clues. You can look at the types of rocks you find in one part of the world, and they match up. They line up with rocks in another part of the world. So those are all pretty good evidence that the continents at one time were all put together.
Okay, so this picture shows you the major tectonic plates of the world. What plate tectonic are we in? If you look carefully, you can see that we are on the North American plate.
Okay, when we say that tectonic plates are moving, they are, but they're only moving a few centimeters a year. So really we don't notice that we're moving, but over a period of hundreds, thousands, millions of years, you can see a pretty big difference in how they move. Now, we're going to talk about 4 different types of movements these plates can have: divergent, convergent, transform, and subduction. And we'll talk about all of them individually.
Okay, so why do we get things like earthquakes and volcanoes? When the plates crash into each other, that causes earthquakes and volcanoes. There's a very famous spot of volcanoes called the Ring of Fire, and this is a very active region of subduction where the plates come together.
Okay, so we've been talking about these plates and that they're moving, but what's causing them to move? Well, what's causing them to move is the Earth is solid on the outside, but it's liquid on the inside. In fact, it's liquid that's very hot. Magma is inside the Earth, and that magma, as all hot liquids do, moves, and it moves in a process we call convection. Convection means it moves to the top, cools, and goes back to the bottom in a big circle. Well, those big circles flow, and they make the plates that are floating on top move one direction or another, depending on which way the convection current flows. So plates move because of convection.
The mantle flows because of convection currents. convection currents are caused by the very hot material at the deepest part of the mantle rising and then cooling and sinking again, repeating the cycle over and over.
Okay, we said we were going to talk about how the plates move. Well, when they move towards each other, we call that convergent. They converge, they come together. So that means they crash into each other. And that results in things like mountains and forming of new plate, as you can see in the pictures right here.
Okay, so as the plates move, one of them will push the other plate underneath it, and the one on top will come up and form a mountain. The one underneath will eventually melt, and as the plates move, they can also cause earthquakes between the boundaries of the plates.
Okay, another way plates could move would be away from each other. And we call moving away from each other divergent. So these are divergent boundaries. That means that the plates are moving away. Of course, that makes kind of a hole where the plates were, and we call that a trench or a ridge, because what happens is new lava comes up and forms new crust. We'll talk about that.
Alright, another type of movement is divergent, where the plates move away from each other. When the two plates move away, there's a hole basically left in the earth in which the magma will come up from the earth, it will cool, and it will create new rock.
Okay, well, plates can go move together, they can move apart, or they can kind of move sideways. Like if one plate moves right and one moves left, that's called a transform boundary. It's side by side. Now, a lot of the times when you see this is what earthquakes are caused by.
Okay, there are a lot of earthquakes in California, and one of the reasons is because it is home to the San Andreas Fault. These plates shift side to side, they move side to side, causing earthquakes to occur.
So, if you don't learn about plate tectonics and continental drift, you could find yourself at fault. In fact, the San Andreas Fault, yeah, that's the one with all the earthquakes. So if you see a sign saying San Andreas Fault, hey, you need to get out of here, because you could get shaken and baked and volcanoes and oh my, it just sounds really bad.